We're going to start at the beginning and open up iTorque Game Builder. We're going to go to the Applications folder, into iTorque 2D 1.5, and then into the TGB folder. What I like to do is right-click and create an alias for it. And once I have that alias, I can move that onto my desktop. Looks like I copied it. Let's go ahead and get rid of the other one. And let's try our new desktop shortcut. And there we go. We have the option to create or open a project. Let's go ahead and create a project. We're going to name it iPlatformer. After we hit create, the editor window opens. Now we can start adding assets for our game. I've already downloaded them and placed them on my computer, so one at a time. Select the asset and click open, and you'll notice that they populate under static sprites, scrollers. Let's go ahead and create another image map and take the mini tile map, and then let's go ahead and add the player animation sprite sheet. If we double click each of these images, we'll see some options. This is the background image map, and it's fine just the way it is. But we want to make sure that we change the filter mode to none and turn the filter pad off. This is discussed in the forums over and over. Okay, this is a different type of image. There's actually 4 images inside of here. This is known as a sprite sheet. So instead of a full image, we're going to say that it's a cell image. It's a 4x4 cell, but the cell count X and Y are -1. I believe that's an automatic setting. It determined that each cell is 128 pixels across, and it looks pretty good. Again, we're going to take off filter mode and filter pad, and then save it. You'll notice that it changed from the image of 4 tiles into 1 tile, and now it has this 1 through 4 underneath it, which lets you select the state of that particular sprite, or the frame rather. Okay, now we're going to do the same thing with the last one, the player image map. We're going to change it to a cell as well, but obviously it didn't calculate exactly what's going on properly. We actually have a 4x4 grid, so we can manually change it to 4x4. And now there's only 1 sprite per grid. Again, we need to take off the filter mode and uncheck filter pad and click save. Now we have a 16 frame animation, even though it doesn't use all 16 frames. Looks like it uses 11. Okay. Now we need to add level data blocks, or edit our level data blocks. This tells iTorque what images we're going to use in our current level. I'm only going to add the background image right now to show you how important this feature is. Okay, I've added the background image to the level data blocks. Now I'm going to drag the background image onto the screen. It's way bigger than our project is, so let's go ahead and resize that to the dimensions of our iPhone application, which is 40 by 320. And let's square that up at 0, 0. And we see that it lines up perfectly. Let's go back to the Create tab again, and this time we'll drag the player image map on. He's pretty big, but that's okay right now. Now let's go ahead and run the application. I'm going to select iPad, and we see that we have the background image, but no ninja. Now the reason for that is because we didn't add them to the level data blocks. I go back into the level data blocks and add both the player and the tile, because I'll ultimately need it, and then rerun the game. We'll see our background and our ninja. Now we can erase that static sprite from the screen. Go ahead and select the ninja, then hit Command X to remove them from the scene. What we need now are to turn these into animated sprites. For the player, we're going to need a player run animation, player jump up, player jump down, and player stand animation. So let's go get busy making those. We click on the Create New Animation button, and it shows us all of the tiled static sprites that we can choose from. We have the mini tile map, image map. That's not the one we want. We want the player. So go ahead and highlight it, select it, and then we get into the animation builder. Now the animation builder, as the name implies, allows you to create animations. We're going to start by creating the player run animation. And we're going to add, by double clicking, the 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th animations. So as we double click them, we notice the little window over to the right shows us a preview of the animation. He's really moving. So we're going to go ahead and slow him down by changing the frames per second down to 15. We're going to leave it a cycle animation so that it keeps repeating over and over. And we're going to change it to player run animation. Now we need to do the same thing for the player jump up animation. So we're going to click the Create New Animation button again, select the image map, and this time we're only going to select the jump up frame, which is frame number 2 or 1 if you're counting from 0. Again, we're going to change the frames per second to 15. I'm not sure if that's necessary since it doesn't really do anything. And we're going to name it player jump up animation. We're going to do the same thing now and create the player jump down animation. And the player stand animation. Which is the third tile. Sprite, whatever you want to call it. Perfect, so now we have 4 different animations. Let's go ahead and drag the player run animation onto the screen and hit play and see what happens. Nothing. And again, that's the importance of the level data blocks. We've added the base sprite image, but now that we've converted them or created animated sprites out of them, those animations also need to be added to the scene. Now that we add the data blocks and run it again, we have a running ninja. Let's go ahead and remove our ninja from the scene, hitting Command X, and let's go back to the Create tab in the editor. Okay, we're going to start building our level now, and to do that we're going to use a tile map along with the tile map sprite. Let's go ahead and open that up real quick and take a look at it. It says the cell height and width are 128. That's going to make them roughly the same size as the player was, and that was kind of too big. So what we're going to do when we render these is we're going to render them at half size at 64 by 64. So knowing that, let's go ahead and drag a new tile layer onto our screen and set the X and Y to 64, as that's going to be our target size. Now it shows, well, it only shows 4 by 4 the grid, so let's size object to layer, and the grid magically expands. Let's go ahead and actually make this a little bit bigger, maybe 20 by 20, just so we have some room to work in the future. And resize it again. Wow, that is huge. Let's go ahead and move the whole thing so that it's centered in our current view, centered with our current background. Perfect. Okay, you'll notice that while I have my mouse over this, we have a little menu that pops up with icons, and we can choose to edit the tile map through that button, or if we have the tile layer selected, we can click Edit Tile Layer right from the editor. Let's zoom back in a little bit so we can see what's going on. And then scroll down to the tile editing. We have the option to choose an image. I'm going to choose the mini tile map image. Then we have an option to choose the frame. I'm going to go ahead and choose the frame number 1, which kind of looks like dirt. Now, we're ultimately going to want this ground to be actual ground. We want the player to be able to walk on it, so we're going to have to turn on collision for it. And let's go and make sure we have the paint tool selected. And now every time we click on one of these layers, they turn into a clump of dirt. And the little green border around it means that it's a collision layer. Let's go ahead and extend the dirt all the way over to the side. If you mess up, that's fine. Use a little eraser. You can erase the tile and then use the paintbrush to paint it back. Let's zoom in here, and it looks pretty good. So let's go over and save our layer. It'll automatically try to go into the tile maps layer. I always like to make sure I'm in the proper project, which I'm in iPlatformer, project files, data, tile maps, which is perfect. And we're going to call this tile map 1. Now that it's saved, let's go ahead and play the game. We have some ground. Let's go ahead and put 2 more blocks right here so that we won't be able to walk off the screen at all when we render that. It looks like so. Yeah, it looks like we might even have a little screen artifact right here where that doesn't look like an even tile. Well, next time we run it, we'll see if it's still there. Okay, now that we have our background and our level built, we're going to add in our player. Now the player, will represent him with this little running animation. So let's pop him somewhere in the middle of the screen. He is way too big, so with him still selected, let's click on the Edit tab and go over to the Scene Object Property roll-up and change his size. Right now he's 128 by 128. Let's cut that in half. And now he's just a little dude. Let's go ahead and run this. And voila, our guy is running in the middle of the screen, kind of just hovering there unnaturally. Nice thing about Torque, we can add physics to our objects so that they behave a little bit more normally. Let's scroll down to the physics rollout, and with our ninja still selected, let's make sure that he's going to use physics. And let's go. Alright, still nothing. Alright, even though we told Torque that we wanted physics to be applied to him, there are no forces acting against him. So, there's no gravity, there's nothing hitting him, there's no recoil, nothing like that. So we need to add a force. And one force that I like to add in is gravity. And gravity is a constant force, so we have a section for constant force. And we can give a value for the gravity So let's go ahead and give it a value of 500. And it'll be in the Y direction because it's up and down. I also like to use a gravitic scale sometimes because it seems to make some of the motions a little bit more natural. Let's go ahead and take a look at what we've got so far. Alright, there he goes. Looks like he's even speeding up with gravity. Oh, and he went right past our ground. He was supposed to stand on that. Well, that's because the player object isn't colliding with anything, or we're not telling him he's allowed to collide with anything. We've told him that the physics engine can act upon him, but not anything about collision. So if we go to the collision roll-up, we can make him send and receive collision information. After we do that, he still falls through. Why is that? Well, maybe he doesn't know what to do once he collides. Well, he sure does. He's supposed to clamp when he collides. We could also make him bounce or stick or kill him when he collides. So maybe that's not the issue. Okay, well, he's not colliding with the background, or not supposed to anyway. It doesn't look like he is anyway. He is supposed to collide with this sheet, the tile map layer. So let's take a look at the properties of the tile map layer. Look, it's not sending or receiving collisions either. So let's go ahead and... No, it won't let me send collisions. I wonder why that is. Probably because it's a passive object. It can only receive the collision information. That would be my guess. Alright, so now that it can receive collisions, and the player can send and receive collisions, let's see if we have some more realistic output. And what do you know? The physics and collision appear to be working. The object dropped with the force of gravity, and once it got to the ground where it collided, it could no longer move. So I think we have a little success. Now that we have collision and physics set up, we need to make the main character in our game a little bit more responsive. We need to give him some functionality. We need to be able to reference him. We need to be able to act upon him. So the first thing we're going to do is we're going to select our ninja, go to the Edit tab, and go down to Scripting Rollout. Now, we can give him a name if we want. Let's go ahead and just call him a player. And then let's also give him a class. Let's call him player class. Now, we're going to give him a name so that we can directly reference this object by using player. And we're going to give him a class so that if we wanted to, we could apply certain attributes to him or any other objects that we want to consider a player. Maybe we will, have a zombie or a werewolf or something as another player, but they will share the same player class, so they get all the functionality of the player. Okay, now that we have that little piece set up, let's go to our Project tab and open up the iOS project. Okay. Let's make sure we're on the correct project. Let's open up our resources folder and look at our scripts. And it appears we're in the right one. Xcode likes to open the last open project a lot of times, so if I'm not sure, I'll just go to File, Open, and then navigate all the way down through Build Files, Xcode iPhone, to the Xcode project itself. And it didn't change, so that's the proper project. Okay. The next thing that the tutorial from TDN wanted us to do was create a player CS file. Now, creating new files in Xcode can be a problem, at least for me, because it always wants to stick them into a folder that I don't want them in. So I'll usually go back to my application folder, into my project, into my scripts folder, and then I'll copy the game CS file a few times. So I just have some files I can work with. And I'm going to go ahead and rename one of them player class. When I go back into Xcode, I see that my player class and game copies have automatically been picked up. So let's go ahead and open up the player class. Use Command A to select all your text, and let's delete it. Now the first thing the tutorial has us do is create the onLevelLoaded function for the player class. So let's go ahead and start that. So function player class, and this double colon denotes that the following function name is only going to be available to objects that are of the player class. So we could have multiple onLevelLoadeds, but only this one is going to respond to the player class objects. And onLevelLoaded needs two different parameters passed in, this, which is the object itself, and the scene graph, which is basically the level file the object's going to reside on. Okay, the first thing we want to do is set up a global variable called player and make him equal to the parameter that's being passed in, or the object, this. So as soon as the player class is loaded, we're going to make a reference in this global variable for him. Okay, the next few lines are actually to map keyboard shortcuts, and so we're not on a device that has a keyboard, so those aren't going to do us any good. So we're not going to worry about those at all. And the last thing it has us do is enable the update callback on the player class object, so that we can use the onUpdate function for it. Now, but let's just go ahead and keep it in here anyway. So the object is going to be our player, and the player's object is going to run an internal method to allow his update callback to be used. The next thing we're going to do is we're going to set up the actual functions that the player is going to be able to do. We're going to let him move left. We're going to stop him from moving left. He's going to move right. We're going to stop him from moving right, and he's going to be able to jump. So let's set up all of those functions right now. So function player class. Actually, we don't even have to reference the class. We're just going to, since we have the global variable, we're just going to call the functions player left, player right, and so forth. They're going to be class independent so that we can call them from anywhere. So function player left we're going to take the player, and we're going to create a dynamic variable in line here called move left, and we're going to set that equal to true. Now we're going to create a function for player left stop. Oops. Have my right shift key mapped to showing the desktop. So the same thing, we're going to take that dynamic variable and change that from move left to false. We need to do the same thing for player right. As well as player right stop. And then we need to set up the function for player jump. We're not doing a whole lot here other than setting up variables that will tell the engine whether or not we're moving, and then when we're tracking the button movements, then we'll actually put these into play. And we have to create our buttons and add those onto the scene as well. Okay, here we have a little bit of logic. So we're going to check if player.airborne is true, or if it's not true rather, and if he's not airborne, then we're going to set his linear velocity for y to be negative 150. And then we're going to set his airborne variable to be equal to true. So when we jump, if he's not already airborne, we're going to give him a y velocity of negative 150, which should move him up. And then since we've already enabled physics on him, the force of gravity should work against him at the same time, and we should get the up and down action. Now that we have the functions set up that tell the player object whether or not he's moving left or right or jumping, we need to put in the actual code that will make the object on screen move. We're going to do this similarly to the TDN tutorial. We're going to split it up into horizontal and vertical movement, but we are going to focus on the horizontal movement right now and then implement the buttons and then make sure that that horizontal movement works before we move on to vertical. So let's start off with a player class function called update horizontal. We get a copy of the actual player class object passed in for us, and so we will use that. Okay, the next lines are to determine whether or not we can move more left or right. In other words, if we're already going right and we hit a wall on our right hand side, do we continue trying to move right, or do we just make the character stop and other than animating bouncing off the wall? So for that we have to check to see if this, well, first of all we're going to see if we're not moving at all, or if we have both the left and right buttons down at the same time. So we're going to look at the move left variable and see if it's exactly equal to the move right variable. If they're the same, in other words, they're both moving or they're both not moving, then we're standing still. In either case, we want to set the linear velocity in the x direction to 0 so that we aren't moving at all. And then we will return to get out of this function. Now, we need to see if we're moving left. If we are, then we have to make another check to see if we are against a wall on the left. So we're going to use a variable called against left wall. and we're going to check to make sure we're not against the left wall. So if we're not against the left wall, then we can set our velocity. I'm going to use -100 so that it's a more dramatic effect. We're going to wind up having to go through these settings later to make them as realistic or as or get the feel and look that we're looking for in the game. Okay, so there's also a line that says to set against right wall equals false. So if you're not against the left wall, then it's automatically saying you're not going to be against the right wall either. But you know, what if you're in between two bricks? You know, I could see that potentially being a problem. If you're in between two bricks and you're falling, you might want them to bounce in between the bricks. This would prevent it. So we're going to go ahead and leave that. We'll go ahead and just leave it in. Let's try to make this as close as possible to the original. So we're going to set against right wall equals false. Okay, now if we are actually against the left wall, then we're not doing anything at all in the move left. So if we are actually moving right instead, we're going to do the same check to see if make sure that we're not against a right wall. And if we're not against the right wall, then we're going to go ahead and let him move to the right. And again, we're going to give it a nice large value. And set that against left wall equals false. And in the demo on TDN, they actually have those lines first. Let's go ahead and match that. Now, if our variable is moving right on this, then we will set our linear velocity appropriately, and if it's moving left, then we'll set its velocity appropriately as well. Unfortunately, right now, nothing's calling update horizontal. Now, we're going to skip over the update vertical piece, and we're going to actually just start implementing the onUpdate for the player class. Now, that's important because we've enabled the update callback on the onLevelLoaded piece. So, obviously, if we need the player to do something over and over again, it's going to need to happen while he's updating. So let's set up, let's set up a player class on update method. Again, we'll get a copy of the player object passed in to us. And when we do have it, we're going to run a method on it. Let's make sure I have my double colons in there, otherwise we'll get a script error. So, first thing we're going to do is we're going to update horizontal. The next thing it says is to update vertical and to set current animation. So let's go ahead and make sure that those are in as well. We haven't created the update vertical method yet, so let's comment it out for the time being. Now that we have our player class script created, we need to make sure that it gets processed when the game runs. To do that, we're going to go into the game.cs file located in the scripts directory, and we're going to find the function start game, and we're going to begin entering code there. I like to put a comment in right where we load the scripts. Just so I don't forget where they are. And then we load a script by using the exec command. This is a little different than iTorque 1.4 if any of you are upgrading. We don't have to use the tilde or the dots or anything like that anymore, but we do have to specify that it's coming out of the scripts folder. And then we type in the name of our script, which is playerclass.cs. Okay, we're at the point where we need to add some buttons to this scene, and I'm thinking we're going to use the button behavior that's included with the feature demo. That way everyone can try the same thing. Open up the feature demo, go to your project files, your scripts, your behaviors, and it's under GUI, and we have a generic button CS file. Let's go ahead and copy that. We'll go back into our iPlatformer. We'll paste it right there. Touch drag is one that I think gets included with every project. There's probably a way to change the template too to get whatever behaviors you want into any new project, I'm sure. Okay, so we have the behavior in. So let's go back to Torque Game Builder. And I've already added the image for the button, which also comes from the feature demo. It's called barrier circle image. So let's go ahead and drag one of those on the screen. Oops, wrong guy. In fact, let me show you how to delete an object, and I'll add it back in real quick. You mouse down on the object, grab it, and then drop it in the trash. You'll get a little message saying, asking if you were sure you wanted to delete the material, and just say yes. And also, you have to delete any orphaned images from the level data blocks editor, otherwise weird things could probably happen. Okay, next we're going to add the image back in. So we're going to go ahead and choose the barrier circle image, and again that's in the feature demo project data images folder. Okay, once we bring an image in, we always remember to add it to our data blocks if we want it to show up on this particular level. And then we can drag it in. We'll drag one in for the left mouse button, and we'll, and drag one in for the right mouse button. Let's go ahead and edit the button. Okay, for these things to respond, they have to be part of a class. I'm not exactly sure why. It's just the way it was written. So we're going to give each of these the class of button in scripting under the Edit tab. Okay, we also need to put that behavior on. So under your behaviors rollout, choose generic button and click on the add symbol. You want the click image to be the same image as what's being displayed, so we'll use the barrier circle image. And then for the method, we are going to use the player right method, except we don't need the parentheses. So just player right there. Or I'm sorry, that one's player left. Now for the right mouse button, we're going to also add a generic behavior. We're also going to make sure it's using the same image, and we're going to call this one player left. And it's also part of the button class. For the generic button behavior, we need to make sure that the functions we specify in the behavior are actually functions that respond to the class for the button, which we named button, We do that by inserting the class name before the function call. So for player left left stop, player right stop, and player jump eventually, because that will be a button. Give it a shot, see what happens. Okay. Oh, the buttons are actually working now. We're sliding over to the left, but there's nothing to control when we're stopping. Let's see, let's try to slide to the right. Right doesn't seem to be working. Let's take a look at why right's not working. Let's try it just by itself to make sure it wasn't being defeated by the left button. No, it looks like they're both going left for some reason. That's not right. Let's look at these buttons again. Okay, this button is using player left, and so is that one. Well, what do you know? So let's use player right for that button, and then resave it and rerun it. Okay, we're getting nothing from the left or from the right button. And I think that's breaking the left button as soon as we do it. Let's take a quick look at the code. The left button seems to be working fine. Player move left equals true. Let's look at the right button. Move right equals true. Okay, but that's not where the movement actually happens. The movement happens in this update horizontal. Okay, so the left one's working, so let's look at that. So if we're moving left, we're not against a wall. We set the right wall variable to false, and we set the linear velocity x to negative 100. Okay. So if we're moving right, we check to make sure we're not against the right wall. We set the against left wall equals false, and then set the linear velocity to 100. Ah, there's the problem. We need to specify that we're setting linear velocity x. Otherwise, set linear velocities are going to expect two parameters, an x and a y. When we say to set the x only, it only wants the one parameter. We probably could modify this to work with just linear velocity, but then we want to keep the horizontal and vertical movement separate. So I think this is great where it is. Let's go back and save that and run Torque Game Builder one more time and see where we're at. Okay, we're falling, pushing the right button, and we're going right. Perfect. Now, nothing's stopping us from going right at the moment, which is a limitation of what that behavior can do. So let's go ahead and stop, make sure the left button's working discreetly as well. Let's try to run it in the iPhone this time, see what happens. And sure enough, we are moving. And what's funny is it seems to not start moving until I let up the button. So that's going to be a topic for another time, I think.